Today, in this session, we are going to discuss about waves, important 8 marks questions with answers. We are going to give the explanation. Let me start. Explain the formation of stationary waves. So, we need to explain the formation of the stationary waves in a stretched strings, and hence we have to deduce the laws of transverse waves in this stretched string. So first, if the two ends, if this is the two ends, one is net and another one is bridge, in between these two there is a string. If you pluck it in between these two, then it will starts to create the nodes and antinodes with different overtones. This is the formation of the stationary waves in the stretched string. So let me see the explanation in written. See, a stretched string is fixed at both ends. So here this is one end and this is the second end. When it is plucked at midpoint, so at midpoint here we are going to pluck two reflected waves of same amplitude and same frequency and same wavelength at the ends are traveling in opposite direction and overlap along the length. Then the resultant waves are known as the stationary waves. So here there is a two waves are overlapping in opposite direction. One wave I considered as y1 is equals to a sine omega t minus kx, which indicates the wave which is moving in positive forward direction in positive x-axis. If I consider the reflected wave another which is in opposite direction, y2 is equal to a sine omega t plus kx, which is in negative direction like this. So it is negative x direction. If these two are overlap each other, and it will create the stationary wave. Then the overlap I considered as y1 plus y2. This implies a I taken the common, therefore sine omega t minus kx and plus sine omega t plus kx. So here this formula is looks like sine a minus b plus sine a plus b. Then it will becomes as 2a, this is the same, and here sine b cos a, sine b cos a. Therefore here this is the kx term and this is the cos omega term. That means here I consider this is 1. Here I am going to consider that sin kx and cos omega t. So kx it will consider as one is node, it will denote node, and another one term denotes antinode. So here node and antinodes. Now the distance between node and node. If the distance between node and node is nothing but lambda by 2, and antinode to node, the distance between the antinode to node is lambda by 4. That you can see there. If this is the node, and if you consider there is another node which is formed here, now you can see here this is antinode and this is node. Now antinode to node there is a distance lambda by 4, and node to node it is the distance is lambda by 2 that I mentioned here. Now see that overtones of the first harmonic and second harmonic overtones and the third harmonic overtones. Now see the first harmonic here I consider if the strings are stretched between the two ends and it creates the maximum overtone is I consider this. This is the first overtone. In the length of L it produces wavelength is lambda by 2. This is the first overtone. Then the frequency formula n is equals to V by lambda 1 because it is first harmonic. Now here this is the first harmonic, so that's why I mentioned as lambda 1. Now from the diagram, L is equals to lambda 1 by 2. This implies lambda 1 is equals to 2L. This lambda 1 I am going to substitute in the first equation, which I considered as n is equals to V by lambda 1. Therefore V by lambda 1 means here 2L. Now we know that V is equal to transverse waves in the stretched string is T by nu, where T is tension and nu is the linear density of considered string. Therefore n is equals to 1 by 2L. Into V place I am writing square root of T by nu. Therefore the first harmonic frequency n1 is equals to n, whereas the value of n is equals to, we know that 1 by 2L square root of T by nu. And coming to the second harmonic, n is equals to V by lambda 2. Here also we consider the two ends of the stretched strings win the length of L with the wavelengths, or here you can see here from here to here it is lambda by 2 and here to here it is lambda by 2. Therefore there is 2 lambda by 2. Therefore L is equals to 2 into lambda 2 by 2, because from here to here it is 1 lambda by 2, here to here 1 lambda by 2, there is 2 lambda by 2, but it is a second harmonic, so I considered as lambda 2. From this implies lambda 2 is equals to 2L by 2 by making the cross multiplication. By substituting this lambda 2 value in the n value, then n2, this is the second harmonic, n2 is equals to V by lambda 2. In the lambda 2 place 2L by 2, that will becomes as lambda 2 is 2L, here by 2 will becomes as multiplied. Therefore n2 is equals to 2 into 1 by 2L square root of T by nu, because we know that the V value is root of T by nu from the transverse waves velocity in the stretched string. Therefore n2 is equals to 2 into this total value is equal for the n. Therefore n2 is equals to 2n is the second harmonic. Now coming to the third harmonic, n3 is equals to V by lambda 3. This is also contains the L length of the string, and it creates a here to here. That means from here to here it is 1 lambda by 2, and here to here 1 lambda by 2, here to here 1 lambda by 2. Therefore totally 3 lambda by 2. Therefore L is equals to 3 lambda by 2, but lambda here I considered as third harmonic, so it is lambda 3. This implies lambda 3 is equals to 2L by 3. Now n3 is equals to V by lambda 3 means 2L by 3, that will becomes as 3 by 2L. Now n3 is equals to 3 into 1 by 2L into V, but we know that V is equals to root of T by nu. This is the linear density and tension relation with velocity. Therefore n3 is equals to 3 into 1 by 2L into square root of T by nu. Therefore n3 is equals to 3 into this total term 1 by 2L square root of T by mu becomes as n. Therefore this is the answer. Therefore n1 is equals to, here we got n, and n2 we get 2n, and n3 you got 3n. Now by making the ratio between the n1, n2 and n3, then it will becomes n is to 2n is to 3n. Therefore n1 is to n2 is to n3 is equals to 1 is to 2 is to 3. This is the relation of the frequencies in the first and second and third harmonics. Now let me start the laws of transverse waves in the stretched string. Before that, the frequency n is equals to, we know that 1 by 2L square root of T by nu. Let me start the three laws of the frequencies, stretched strings. Now the first law of transverse wave, first law of the transverse waves in the string n is inversely proportional to L. Therefore, n1 is equals to 1 by L1 and n2 is equals to 1 by L2. Therefore, n1 by n2 is equals to L2 by L1. Therefore, n1 L1 is equals to n2 L2. This is the laws of the transverse waves, which is in first law. Now coming to the second law of transverse waves in stretched string. Now this is n is directly proportional to root t. Therefore, n1 is equals to root t1 and n2 is equals to root t2. Then n1 by n2 becomes square root of t1 by t2. T1 by T2. This is the second law of the transverse waves. In first law, the tension T and linear density mu's are the constants. Similarly, in second law, the length and linear density mu are the constants. Now, in third law of transverse wave stretched in the string, n is inversely proportional to 1 by root mu. Therefore, n1 is equals to 1 by root mu 1, n2 is equals to 1 by root mu 2. Then n1 by n2 is equals to square root of mu 2 by mu 1. This is the third law of the thermodynamics. Third law of transverse waves in the stretched string. This is the one of the important question which is coming for the main public exams in intermediate. Now the second question: explain the formation of the stationary waves in an air column in open pipe. Derive the equation for the frequencies of the harmonics produced in the different notes. Now, what is the open pipe? If the pipe is open at both the ends, is called the open pipe, where n is equals to v by lambda. Now, how it is open means, see here, this is opened in both ends. Now, the stationary waves are formed by the reflection and reflection at the ends of the pipe and superimposition of the incident of the sound waves at these ends. Now at this end and this end, similarly here this end and here this end. Now you can see that here the frequencies of the waves, here this is the compression, here and here, similarly here and here. These are the waves are created by the reflection and superimpositions in the open pipe. Now you can see that the three overtones in the open pipe. This is the first overtone in the pipe, this is the second overtone, this is the third overtone. In first overtone, the frequency I am going to consider here, it is n1 is equals to v by lambda 1. Similarly, n2 is equals to v by lambda 2. Similarly, n3 is equals to v by lambda 3. Here in first overtone, we have only one node. Here it is one node, and here we have two antinodes. Here it is 1 and 2 nodes, and 1 2 3 antinodes. And similarly here 1 2 3 nodes and 4 antinodes. These are the overtones, nodes and antinodes in the open pipe. Now let me start where it is in the length. We are considering L length, and here see from here to here it is lambda by 4, here to here it is lambda by 4. Then the total wavelength lambda 1 is lambda by 2. Here it is lambda by 4, that is lambda 1 by 2. Therefore L is equals to lambda 1 by 2. This implies lambda 1 is equals to 2L, where n1 is equals to v by lambda 1, but n1 is equals to v by, in lambda 1 place we are going to write 2L. Therefore n1 is equals to v by 2L I have written as a n. This is the first overtone. Similarly for the second overtone, now from here to here it is L. Now here see the lambda wavelength, from here to here lambda by 4, here to here lambda by 4, so 1 lambda by 2. Similarly here 1 lambda by 2, so here 2 lambda 2 by 2 is the wavelength. Now see, L is equals to 2 lambda 2 by 2. This implies lambda 2 is equals to 2L by 2. By substituting this lambda 2 value here, then N2 is equals to V by 2L, and this 2 becomes as multiplied. Therefore, N2 is equals to 2 into V by 2L. But we know that V by 2L is equals to N. That based on equation, N2 becomes 2N. This is the second harmonic overtone. Now coming to the third one, similarly here also I consider this is the L length of the wire. Now here how much of the lambda by 2, see here, from here to here 1 lambda by 2, 1, and here to here 2, and here to here 3. Now L is equals to 3 lambda 3 by 2. This implies lambda 3 is equals to 2L by 3. Therefore N3 is equals to V by lambda 3. This implies V by, in lambda 3 place we are going to write 2L into 3. Therefore N3 is equals to 3 into V by 2L. Therefore N3 is equals to 3 into N. This is the third harmonic overtone. Now by based on this all, the ratios of N1 is to N2 is to N3 is equals to 1 is to 2 is to 3. Now coming to the third question, how are stationary waves are formed in closed pipe? Now we are going to find the stationary waves in closed pipe, and also explain the various modes of vibrations and obtain relations for their frequencies. Now see how the closed pipe, see here this is the open end, and if you see that backside, now here it is closed, this end is closed. Now this end which is closed, there we are getting the node, and here we are getting one node and one antinode. But here 1 and 1, 2 nodes, and we are getting one antinodes. And here 3 nodes and 3 nodes. See 1, 2, 3, 3 nodes and one antinode. So this is the first harmonic. This is the first harmonic, and this is the second harmonic, and the next one is third harmonic. So these are the three different harmonics which are formed in the closed pipe. Now first of all we are going to find the closed pipe. The first frequency V is equals to N1 is equals to V by lambda 1. N1 is equals to V by lambda 1. Now consider this length is L, and here the lambda is what? Here the lambda by 4 is the wavelength. Therefore L is equals to the total length one, L is equal to lambda 1 by 4. This implies lambda 1 is equals to 4L. By substituting this lambda 1 value in this equation 1, then see N1 is equals to V by 4L. I consider this N1 is equals to V by 4L as N. Therefore N is equals to V by 4L I considered here. Now coming to the second harmonic. In second harmonic, N2 is equals to V by lambda 2. Here consider from here to here 1 lambda, see 1 lambda by 4, 2 lambda by 4, and from here to here 3 lambda by 4. See this one is 1 lambda by 4, from here to here it is 2 lambda by 4, from here to here it is 3 lambda by 4. Therefore lambda is 3L by 4. So L is equals to 3 lambda 2 by 4 is the L value. From this, say 3 lambda 2. This implies lambda 2 is equals to 4L by 3. By substituting this lambda 2 value in this second equation, now N2 is equals to V by lambda 2 means what? 4L by 3. That I will write 4L. This by 3 becomes as multiplied. Therefore N2 is equals to 3 into V by 4L. This I can write as V by 4L as N value. So that's why N2 is equals to 3N. This is the value of N2. Now coming to the third harmonic. See, third harmonic is how many lambda by 4s are there? 1, 2, 3, 4, 5 lambda by 4s are there. So N1 is equals to V by lambda 3, but the length L contains 5 lambda 3 by 4. This implies lambda 3 is equals to 4L by 5. So here I consider the lambda 3 value in this equation number 3. Then n1 is equals to v by 4l. This by 5 becomes as multiplied. Therefore n1 is it is an n3 because it is third harmonic. n3 is equals to 5 into v by 4l, that becomes 5 into n. Therefore n3 is equals to 5n is the answer. Now see that n1 here in this equation n1 is equals to, in this equation here n1 is equals to what we got, n. Here you got n2 is equals to 3n, and here you got n3 is equals to 5n. Therefore n1 is to n2 is to n3 is equals to n is to 3n is to 5n. Therefore 1 is to 3 is to 5. This is the answer for the relation of the frequencies which are in closed pipe. Now coming to the next question. What is Doppler effect? Obtain an expression for the apparent frequency of sound heard when the source is in motion with respect to an observer at rest. So here you need to observe that the apparent frequency of sound heard when the source is in motion with respect to an observer, but observer is at rest. Now here source is in motion, observer is at rest. Now see the case. So the Doppler effect definition you can write in the examination: the increase or decrease in the frequency of sound waves as the source and observer moves towards or away from each other. Now in this diagram, now the observer is at rest. Now the observer is at rest, but here source, see the source of the car is moving towards to the observer, Now here in this case the observer is here, at rest. That means v0, velocity of the observer is 0, and velocity of the source vs, and this is in away from the observer, but it is towards to the observer. In these cases we need to derive the equation. Before that, the frequency of sound heard by the observer we are denoting by f0, and frequency of sound produced by the source is denoting by fs, and velocity of the sound in air is v. Velocity of observer, while the observer is in motion, then observer velocity is v0. If velocity of source velocity of source is vs, that means car velocity of source, that means source is in motion, that source velocity is vs I consider. Now the relation of the observer frequency of the sound, observer heard frequency of sound is equals to the v0 plus or minus v plus or minus v0 by v plus or minus vs into fs. This is the Doppler effect main relation. Now let me start the first case. Now here in this first case you observe that the observer is at rest. So observer velocity v0 is equal to 0, but source is moving away from the observer, that which is vs. Now see, if the observer is moving from here onwards, so once again you see that now here it is the source. So here it is the source and here it is the observer. Now observer is here. Now the velocity of the ambulance sound will move in towards this direction. Velocity is moving in this direction of sound. This is the velocity of sound, but the velocity of source is moving with velocity vs in this direction, the velocity of the source. Now see, from the observer, the source at initial state of the source is placed in the length of L, in the place of L length. Now the velocity when the source is at S position, now the velocity of the sound reaches the observer within time t1, then the velocity v is equal to formula length by time t1. This implies time t1 is equals to L by v, or you can also write L is equals to t1 into v. This is the equations of the first case when the object is at S position. If the source is moved from S to S dash position. Now the S to S dash position. Now from here to here, the length we don't know, we need to find it, but we know that time from here to here we are considering as t0 time takes, it takes t0 times to reach the S1. Then here the velocity of the ambulance is Vs, time is t. Velocity time, if we know that, then length we can find. The length L we can write as here Vs into t0, because it is t0 Vs. So this is the length. Now coming to the case 2, then you can find that from here to, from the observer, now the ambulance frequency what it is means t2, time taking to listen. See, from here to here, that means from the ambulance to here the observer listening that sound with the frequency of V in the time t2. Then the t2 time t2 is equals to t0 plus here the length is L, in the here the length is V S t0 by the total velocity is velocity of sound is V. Therefore t2 we know that, and t1 we know that. T1 is equal to L by V, and t2 is equal to L plus Vs t0 by V. If we consider t3, then what will be happened? Here another one t2 t0 will be added, then it is 2 t0 plus L plus 2 Vs t0 by V. So that means if Tn means what will be happen? N t0 plus L plus N Vs t0 by V. From these equations, see, t1 value is L plus V. Here you can see that t1 value is L by V. Here tn value is N t0 plus L plus N Vs t plus 1. That is tn plus 1 value. Now coming to that, if t1 tn plus 1 minus t1, that is equal to tn plus 1 is what? t0 plus n t0 plus L plus L plus n into Vs t0 by V minus t1 by V. Now n t0 plus L by V plus n Vs t0 by V minus t1 by t1 is L1 by t1 is equal to L by V minus L by V plus L by V gets cancelled. This implies tn plus 1, that is it is tn is equals to n t0 plus here see n t0 plus n Vs t0 by V. If this is the tn but we need t, then t is equals to tn by n. This implies n gets cancelled, then t0 I am taking the common, then 1 plus Vs by V. Therefore this implies t is equals to t0 into V plus Vs by V. If we know the t, then what is frequency? That frequency 1 by n is equals to t, that is 1 by n is equals to t. Therefore 1 by t is equals to, this implies 1 by t is equals to n. Therefore n is equals to 1 by means it is reversed, then n is equals to 1 by t into V by V plus Vs. This is the apparent frequency heard by the observer. If the source is moving away from the observer, if source is moving towards to the observer, then frequency n is equals to 1 by t V by V minus Vs. This is the equations for the frequencies apparent frequency observed by observer. Now this is the towards to the observer. Then n is equal to that previously we similarly we written n is equal to 1 by t into V by V minus Vs.